my testing data. This is not really, this is just kind of an arbitrary idea. So this is the training, and this is my test. Now, you could imagine that what might happen is that I might make an AI, and hopefully the idea is when I train, I only show it these two examples, and I want it to learn how to add. But you might be recognizing you're like, oh, it only a naive AI might just no matter what learn over time. Like at first it might be like, okay, let's do underfitting. So what would underfitting look like? In the underfitting situation, 3 plus 1, it might think that it's equal to 5, and 2 plus 2 is equal to 6. That's not really right. So we want to keep training so that it gives me the correct answers. So let's say I keep training and I get to this point. So now this is like kind of the optimal point, or the best point I can do. And let's say at this point it's like 3 plus 1 equals 4.1, and 2 plus 2 equals 3.8. That's not really too far off, but it's still not correct. But let's say I kept training even further and further, and I started overfitting. So in the overfitting situation, now when I put these in, it'll say 4 and 4. Great, that's correct. But there's an issue here. In the overfitting situation, it might just say 4 for everything. So now when I put 6 plus 4 in, it might literally just say 4 because it's learned that the answer is just generally 4. But ideally, and then to kind of compare this to the testing set, in the underfitting situation, 6 plus 4 might give me, like in this kind of underfitting situation, it might give me 7. That's not correct. In the near optimal, where I'm between underfitting and overfitting, I might get 6 plus 4 equals 8.9, which is not really correct, but it's not bad. And then if I kept overfitting, it might eventually just say 6 plus 4 equals 4. And that's even worse than 8.9.
Okay, should the data scientists be providing us daily or weekly reports of the underfitting and overfitting, overtraining?
I guess it depends on like, I mean, they can like, the idea is once you give them this data and they start learning or training the models, they should be able to give you this kind of at any given point. So like, I guess like typically anytime you're meeting with them, like I don't know how often you would meet with your data scientists, but anytime when you meet with them, you should be like, how is our accuracies doing? How is our recall doing? How is our like precision doing?
What are hyperparameters, or how are they used in the model?
So essentially how hyperparameters kind of work is you can think of it at a high level. It's essentially like kind of the structure of your model. So let's say that I have, so for example, let's say that I want to be able to make an AI that takes in I want to predict whether a house is a good investment or not. So I have some data about the house maybe. So there's input data. Maybe I know the square footage of the house. Maybe I know how many bedrooms there are. Number of bedrooms. Maybe I know how far it is, like distance to nearest school. And maybe I know, who knows, like other information about the house, like previous owners, who knows? Just, I have a bunch of information about it, right? So for example, like I can turn, now if you give me a house, like a house can be described as a vector where like the square footage is 500, the number of bedrooms is 3, the distance to a school is 50 miles, and the previous owner was, I don't know, Kate Middleton or something, I don't know, whatever. So now there's a question. So essentially I want to be able to take these numbers and somehow essentially take this thing and output maybe literally a 0 or a 1, where 0 means do not invest in this house and 1 means invest. So somehow I need to take these numbers and like, actually I'll just like, you can do string, like I already showed you how you can take strings and turn them into numbers. So for now, let's just say Kate Middleton is represented by the number like 753, whatever. You have to turn everything into numbers for your computer to be able to use them. So somehow I need to combine these numbers to turn it into another number. So you need to decide how you want. So maybe one way that I'm gonna say is I'm gonna take the square footage, so let's call that like, so let's call this the variable that's represented as x1, this is x2, this is equal to x3, and this is equal to x4. So what I might want to do is I might decide the way that I'm going to tell you this number is I'm going to take x1, multiply it by the number, like the number 30. I'm going to add that to 50 times x2. And then I'm going to take this output and I'm going to like divide it by like 20 times x3. And I'm going to add it to like 90 times x4. And whatever this outputs, I'm gonna like, it should hopefully be like 0 or 1. And if it's like not 0, maybe it'll scale to, maybe like the way that I've formalized this or the way that I structure this, it should give me a number between 0 to 1, and whichever number it's closer to, 0 or 1, I'll just say it is. So I have x1, x2, x3, x4. That's like the input into my data, correct?
That's not the hyper, that's the input. That's not the
That's the
hyperparameter.
input. The numbers 30, 50, 20, and 90
Or the hyperparameter.
No, these are just the regular parameters. So I've chosen these already, but these are actually something that you would learn over time. So this is actually, in a more general sense, 30 can be called W1, and I'll multiply W1 by X1. 50 might be at W2, and I'll multiply W2 by X2. Divide that by 20, which I'll call W3, and I'll call that X3 times X3 plus 90, which is W4 times X4, and this should output some number between 0 to 1. So now let's say I don't know these numbers. So what I would do is don't ask why you multiply these, add, multiply, like this structure, the overall structure is called the hyperparameters or the structure, and there might be, there's other types of hyperparameters, but they're essentially this kind of meta level choice that like, I want to take some number that I don't have called W1, multiply it by X1, and then I'm going to add it. This structure is called the hyperparameters.
The structure or the equation, or is that the same thing?
Same thing.
Okay.
But once I have the equation of the hyperparameters, there's kind of this question, well, what are the actual W1, W2, W3, W4? You learn this through AI. Your AI will eventually spit out that the optimal thing in order to get X1, X2, X3 for X4 is to output the zeros and ones that match your training data should be like W1 should be equal to 20, W2 will be equal to 40. It'll just spit this out. So these W's are your parameters, but how you combine your parameters with your input in a structure is called your hyperparameters. So I might decide another hyperparameter setup might be that like I'll take and like divide all of this by like W4 times X3 or something. Who knows? The point is, and this is not even I'm not like creating a valid real neural network or any like AI really right now. I'm just giving an example. The idea is this structure, this hyperparameters, and then the model, the parameters themselves. Once I've defined the hyperparameters, like I need to learn what the actual parameters are themselves.